Today, I will be presenting my individual assignment on rail transportation, with a specific focus on the remarkable system of the SBB or Swiss Federal Railways. Transportation is much more than just moving people. It is the high-speed artery of an economy, linking cities and communities while being an anchor for social and environment stability. Operators like the SBB are considered global benchmarks for reliability, safety, and digital integration. In this presentation, I will cover the core characteristics of rail transportation, identify the key players, analyze a critical case study on SBB modernization, and conclude with key recommendations. Rail transportation has two fundamental characteristics. First, incredible capacity and efficiency. Rail operates on fixed, dedicated tracks. This allows trains to move massive loads, be it in thousands of passengers or endless freight cars. With remarkable energy efficiency, platoon move, making it the economic backbone for long-distance trade. 2. Unparalleled reliability. The fixed route ensures high predictability and makes the system resilient to most traffic snarls or moderate weather delays. The SBB is the perfect example, having turned punctuality into a national standard, with services often delayed by less than 3 minutes. Let's examine the specific advantages and disadvantages that flow from this unique setup. First of all, high capacity and cost effectiveness. A single train can move immense volumes of cargo or passengers. This translates directly into superior cost effectiveness for long distance. You are moving more per trip, reducing the cost per unit. 2. High reliability and predictability. Because trains run on dedicated, fixed tracks, they maintain tight schedules and remain largely unaffected by traffic congestion or minor weather disruption. 3. Environmental performance. Rail is a significantly better environmentally per unit move compared to road transport, especially when electrified. It is the most fuel-efficient way to move heavy stuff. However, these same characteristics that create the benefits also create notable disadvantages. Critical lack of flexibility. The need for fixed tracks means rail cannot offer the crucial door-to-door service that trucks provide. 2. Massive capital investment. Establishing and maintaining the network requires huge capital investment in tracks, signals, and tunnels. 3. Inefficiency for short distance. The time spent on loading and unloading operation at terminals make rail transport generally unsuitable for short distance or for smaller and urgent deliveries. Moving on to section 1.2, infrastructure and networks. China is currently the undisputed master, having built the world's longest network, connecting millions with lines like the Beijing-Guangzhou HSR. However, the pioneers were Japan. Their original Shinkansen or bullet train routes, such as the one between Tokyo and Osaka, set the global gold standard for never being laid. Europe also features a sophisticated web of trains like France TGV, Germany's ICE, and Spain AVE. These networks seamlessly knit the continents together, connecting capitals like Paris, London, and Frankfurt with fast travel. Precision is paramount in the SBB system. It is meticulously synchronized by the clock face schedule. This timetable uses central nodal hubs like Zurich Hub Bahnhof to ensure trains arrive and depart at predictable times every hour. Let's discuss the crucial policies in rail transportation. The first big idea is splitting the job. To get more competition and better service, governments are making sure the tracks themselves are separate from the companies that run the trains. This is similar to owning the highway but allowing different trucking companies to use it. Next, it's all about saving the planet. Because trains are the most fuel-efficient way to move heavy stuff, policies are aggressively pushing us to ditch the road and take the rail. Finally, the rule keep us safe and connected. On 1.4, passenger rail faces several big challenges. It needs a lot of money, so it depends heavily on government funding, which can change with politics. Keeping trains on time is also difficult because different types of trains share the same tracks, so one delay can cause many others. Building new lines often faces community complaints about noise and lane use, causing long delays. On top of that, there's a shortage of skilled workers like engineers and technicians, making maintenance and upgrades slower. Main players are Swiss federal government. As the owner, it sets the high-level economy and service schools for the country. Second, Federal Office of Transport, known as FOT. This is the main regulator overseeing safety, approving new tracks, and ensuring prices and service quality are fair. Third, SBB, it means Swiss Federal Railways, the main driver, running the majority of all long-distance and regional trains, managing the network, schedules, and stations. Fourth, partner operators, such as BLS and RHB. They work closely with SBB, sharing ticketing and scheduling system to ensure seamless transfer for passengers. That the most important, we have the passenger. They are the most important players. Their feedback and usage pattern directly shape train frequency and the design of digital services. Moving on to the case study of SBB, Swiss Federal Railways. The digitalization and modernization of their communication system from the old GSMR network to a modern internet-based IMS or VoLTE architecture. Internally, SBB needed flawless teamwork between track people, infrastructure, train driver, operation, computer expert SIT, and train mechanics rolling stock. Externally, they faced two big challenges. First, they needed official sign-off from the government watchdog. Second, they partner with giants like Ericsson and Swisscom. Because the network operates 24/7, the migration absolutely requires zero downtime. Ultimately, the external pressure from the BAV, demanding hundreds of field tests, mean failure to secure certification on time will have risked the failure of the entire system. To conclude our analysis, we can draw three key recommendations for the future of rail transportation. First, we must commit to technology acceleration and standardization. Rail operators must stop doing costly, disruptive upgrades and instead spring toward the new 5G communication system. Second, we must double down on sustainability. Government needs to aggressively push people and cargo off the highways and onto the train tracks, using smart policies and financial incentives